Hi, Amy. How are you doing?
Hi, sir. I'm good, thank you. How are you?
Very good, very good. Happy New Year.
Yeah, you too, sir. Happy New Year. Hopefully,
Yeah.
2021 will be a better one.
Much better, right?
Yeah,
Yes, yes. With these vaccines coming up and people really administrating them properly, I think it'll be okay.
yeah, hopefully. So, yeah.
Hmm. So let's continue where we left. We were working on statistics and we saw there are a lot of discrepancies in answering many types of questions. So today, again, I've taken a unit where we have many estimates to do, and we'll see how to do these
Mhm.
estimates in different ways. Okay,
Yep.
so we'll talk about box and whisker plot and see how do we find the mean and standard deviation from box and whisker plot. Okay,
All right. Okay.
this is a very interesting topic, and in most of the books, it is not really covered, and therefore, it becomes difficult to answer the questions based on the topic. How do we find mean and standard deviation when we are given box and whisker plots? So, looking into your requirements, which you really need for GCSE, I worked out on few things. So we'll just focus on those things today. Uh, okay, let me just see how to share this screen with you. Right, so there you go. Correct. So do you see this particular slide?
Yes, I can.
Okay, great. So what I was saying is, we'll see, we are given box and whisker plot, and from there, we need to find what is the mean and what is the standard deviation. To begin with, let me tell you, there is no formula to give you this relation. And therefore, we are
All
going
right.
to have, we are going to really have a logical approach to estimate both mean and standard deviation. So that becomes the base for our lesson today. Okay. All
All
the
right.
formulas I'm trying to give you, or the ways I'm trying to teach you how to estimate, are like helping you to solve a multiple choice question, one. Second, to provide the best estimate in a given situation. Okay?
Mhm.
Right. So I'll take up two examples in this case. The first one here, we have two box and whisker diagrams. As you can see, the one on the left and one on the right, they're slightly different. The one on the left is kind of a uniform distribution. You see the median right in the center, both the whiskers same distance away from Q1 and Q2.
Yep.
So that kind of data represents a normal distribution. So if you see how the data is placed, most of the data will be right in the center. And therefore, you will see that the since most of the data is right in the center, mode is in the center, mean is also in the center, and median is also in the center. All the three are right there, very close to one another, and we assume them to be at the center. So when we talk about box and whisker plot, we name it Q2, the second quartile, correct? Where we know that we have 50% on the left. So this is 25% here, correct? 25%.
Yeah.
So that makes it 50%. And we know each quartile divides into equal parts, four equal parts, where 25% data is like kind of distributed, right? So in the first case, which we are saying represents a normal distribution. So you learn later this particular bell-shaped curve, which is signifying a normal distribution. In that case, mode, mean, and median are all at the same point, and we estimate that value as median Q2 from the box and whisker plot. Correct? So how do we estimate mean and standard deviation becomes slightly easier, I should say very easy, when the data is in this form, correct? Because
Right.
you know what the median is, and therefore, let's look into the characteristics of this normal distribution to understand, and that will help us. How do we answer a similar question when the data is not that well normally distributed? So we say in that case, it is skewed. Either it is more towards the left side or more towards the right side. Correct. So the whisker length,
All right.
second example, you see the whisker length on the right side is much more than on the left side.
Longer.
So we
Mm-hmm.
say this is right skewed distribution. Clearly, in this type of a data, the mode will be somewhere on the left side of median and the mean will be on the right side of median, since there are a lot of data with higher values. Higher values will lead to higher mean, correct? Median is the central value. If you arrange all the elements in increasing order, the number at the center is the median. However, since the weight of the right side is much more, the mean will shift towards the right. Makes sense, right? So the
Yeah.
mean is expected to move towards the right of the median. So now it becomes difficult to find the mean and then the standard deviation from the given box and whisker plot. So we really need to estimate and then figure out by how much should this mean shift towards right when we are talking about right skewed distribution. Does it make sense to you?
Mhm.
Correct?
Yeah.
So that's kind of very important. So let's look into the normal distribution, understand the basic, and then from there we can actually form some boundary conditions. And these boundary conditions can help us solve multiple choice questions and also provide an estimate for mean and standard deviation when the data is skewed either on the right side or on the left side. Perfect.
Mm-hmm.
So in case of a normal distribution, we saw that mean and median have the same value. And since in the given example here, Q2 is at 60, mean will also be at 60. Now, another observation is that the standard deviation can be estimated. Standard deviation is deviation from the mean, right? That is what standard deviation is. And it gives you an idea how compact the data is around the mean.
Mm-hmm.
Correct. That is what it gives you. So generally we say that it is within three-fourth of an interquartile range. So that is biggest big range within three-fourth of interquartile range, right? So we say that
Mm-hmm.
this is somewhere in between this range. Do you understand? Which is three-fourth of that particular range. We don't know exactly where. Well, if it is uh, we can figure this out, but that's an estimate on the higher side. On the lower side, we say it is around 60%. So three-fifths of interquartile range. So on the lower side, we will say that it is between three-fifths. It is closer, so we will estimate that to be three-fifths of interquartile range. So it is somewhere between these two values.
Mm-hmm.
So to estimate, even from a normal distribution, we can use these values, right? So we'll see how we are going to use it in this particular example. The third thing which you also know about is that in case of a normal distribution, the data between the mean and the standard deviation, so if this is their standard deviation, right? In that case, this data is around 34%. So So from mean is like 50% data, correct?
Mm-hmm.
So 50 plus 34 gives you this particular point, which is at 84 percentile. You can say that. So from here, the difference between the 84th percentile and the 50th percentile, which is the mean, gives you standard deviation.
All right. Okay.
So this point is basically mean plus the standard deviation. This point here is the mean. So from their difference, we can actually estimate standard deviation. You get the idea.
Mm-hmm.
This much is standard deviation. And this standard deviation represents 34% of the data when the distribution is normal. You get the idea.
All right. Yeah.
Correct? 34. So we are looking at very important figure 34%. And when you add 50 to 34, you get what? You get 84%, correct? Now we know Q3 is 75%, correct? Q3 is
75.
So when you go to 84 to check where the standard deviation is, standard deviation should there be at 84 minus 75, which is 9% extra
Mhm.
from Q3. Do you see that? So what I'm trying to say is
Yeah.
Q plus 9%. Do you see that? That will give me the position of standard deviation. Does
Yeah.
make I mean standard deviation plus mean, and I can always find what standard deviation is because I've estimated the mean, right? For normal distribution,
But,
mean is Q2. You get
all
the
right, but just a quick thing. When you say 9%, what do you do 9% of the whole
9%
data?
of fourth quartile.
Oh, so
9% of
9%
fourth
of
quartile.
oh,
You
okay.
understand? So that extra, because this is 25% of the data, right? This is 25% of the data. From this 25%, we will see a point which is 9% away.
Mhm.
And for that, we are going to assume linear distribution to calculate.
All right. Okay.
You understand?
Yeah, yeah, I was gonna ask
Like
that.
we
Yeah.
calculated median in previous examples. So
Yeah.
for getting to 9 percentile from Q3, we will say that we can divide this portion, which is from highest value to Q3, right? This is my total region. This total region is being divided into 25%. So this is divided into 25%. We want 9% of it. So this formula should give me the point which is 9% more than Q3. Does it make sense to you?
Mhm. Yeah.
That is
Clear.
going to be our strategy to find the standard deviation for normal distribution with whatever we have learned so far. Is that clear to you?
Yeah.
Correct? So this is our strategy for normal distribution. And now we want to extend this to a case which is not a normal distribution. So it could be skewed towards the right or towards the left. In my example, I've taken the case when the data is skewed towards the right. So when I say towards the right, so in that case, if using the calculations of normal distribution, I am getting a value which is kind of here, I expect the answer to be slightly right of this, correct? Does it make sense to you? Because the data has
Yeah.
been skewed right. The mean itself has been shifted to the right. Since the mean is
Mhm.
shifted to the right, that variation delta will be represented here in my standard deviation also. Proportionally, standard deviation will be shifted to the right.
Mhm.
Correct?
Yeah.
Even when we assume that the amount of information between the mean and the standard deviation is 34%, even then, since the mean has shifted right, my standard deviation will accordingly shift slightly more right. So in that case, what I'm trying to do here is instead of going 9% above, I'm now going 10% above to check my standard deviation. So do you understand the logic which I'm trying to follow here?
Mm.
In case it is a normal data, I'm assuming that it 34% of the data will be between the standard deviation and the mean, which is well known fact.
Oh, right. Okay.
This is a fact. This is correct. Now, we really do not know about the skewed distribution, what should be the calculation. But from our understanding so far, it is clear. It is going to be on the right side of whatever calculation you do for normal distribution.
Mhm.
Since the
Yeah.
data clearly is more towards the
That's
right,
great.
higher value.
Right. Yeah.
Therefore, instead of using 9% from 73, which gives me 84, I could use 10%, correct? At least
Mhm.
that much, correct? Which is
Yeah.
from Q3 10%. So in my formula, only value which changes is this 9 becomes 10. And I can use the same logic to find the standard deviation. Does it make sense to you?
Yeah.
So that is
It's
the
clear.
logic which I am going to follow to estimate the mean and the standard deviation for such questions. We have no
All right.
options as such because there is no book which I have come across which gives you a formula to find this at this stage. Okay,
Mm.
that is kind of
Yeah.
important because we have learned just very few things
Usually,
about. Yeah. Till now, we
Yeah.
have done
Usually the
very few.
questions.
Yes,
Yeah. Usually the questions are just like to say what's happening, not to actually calculate the exact values because
correct.
they don't go into this much depth at school. Yeah.
That
So
is true.
it's good to
Yes.
know this.
You could do all these calculations if you are given raw data. So from raw data, it is
Mm.
not a problem. You have the data, you have the formula, you can find mean and standard deviation from
Oh,
the raw data. But now we are given a box and whisker diagram, not even a group data.
yeah.
Not even the
Yeah.
group data.
Which makes it
From
harder.
yes, from the group data, if
Mm.
you are given the same question, you could actually draw a cumulative frequency graph and calculate. So let's be very clear on it,
Mm.
right? Now we are given a box and whisker diagram, not the group data. We know what Q1 is, what Q2 is, what is Q3, and what is Q4. We know that.
Yeah.
So from there, we have to find mean and standard deviation. That makes it very difficult. You get the idea.
From the box plot, can you draw? You can draw a cumulative frequency graph.
More, no, not exactly, but
You
yes,
can.
but you could.
Like an
Saying that
estimate. Yeah.
25% values are at Q1, then 50% at Q3, 75% here, and 100% below 100% is at H. So definitely you have 4 points, and you can join these 4 points and draw a cumulative graph. Yes, you could.
Mm.
Very approximate,
Oh, okay.
right?
Yeah.
And there also you can do an estimate of mean and standard deviation. But that's you could do that. But this logic,
Yeah.
which I'm today dealing with, trying to share
It's
with you,
better.
may also give you very quick answer. We see we are just working on multiple choice test questions, and for that, drawing a after all, from a graph, you can only read
Yeah.
very approximately, right? But
That's
these
true. Yeah.
calculations will easily give you a number which you can match with the multiple choices and get your answer.
Oh, right.
That is why these
Right. That
numbers are
makes sense.
important and this approach is important. Okay.
Yeah.
So, did you really understand the concept so that we'll move forward and answer both the questions?
Yeah. Oh,
Great.
yes, I did.
Very good. So, let's talk about the first graph, which is normal distribution graph. So, as I was saying, we have a box and whisker plot right there, which is very symmetric. And so from here, we can conclude that we have normal distribution, a bell-shaped curve, where the mean, median, and mode all are right there in the center. Q2 is the value of median, and mean has to be equal to median for this kind of distribution. And therefore, straight away, we can write down that the mean mu is Q2, and in this case, it is 60 in the example taken. I've taken very simple values to work with 20, 40, 60, 80, and 100. Nothing could be simpler than that, right? We have to understand the
Mhm.
concept. Perfect. Now, when we say normal distribution, I have shown you three different cases. See, Amy, this is case one. It could be a bell-shaped curve as shown here. It could also be a bell-shaped curve which is very narrow. Do you see that? This is also
Mm.
normal
Yeah.
distribution. And it could be very wide as shown here. Do you see that? So this bell-shaped curve, depending on your data, could be kind of like this. Relating them to box and whisker means really how far these whiskers are. Correct? You could say that. If the whiskers are
Mm.
longer, that means this is for longer whiskers, and this is for shorter.
Oh, right.
And this is for normal. You can say what is normal for you, that you have to decide. I will say the one which is given to
Yeah.
me is normal. You get the idea, right?
Yeah.
So,
Yeah.
so if I have something like this, kind of, right? If I have something like this, I will say this is longer, right? Do you see that?
Long. Yeah.
So then, if you are given different kinds of box and whisker diagrams, you could visualize the type of normal curve, which could be
Right.
narrow or wider also, depending on the whisker.
Yeah.
Think whiskers as something which is horizontally compressing or elongating, stretching the whole normal curve. You get the idea.
Right.
That is
Yeah.
what whisker literally means here, right?
Oh,
Now,
right. Okay.
in case you are given a whisker which is kind of like this longer one, you should follow higher estimates. Correct? Because it is more spread out.
Mm. That's
More
true.
spread out
Right.
means the standard deviation will be three-fourth of interquartile range. So in this case, I will say that mean is 3 by 4 of interquartile range. You know what interquartile range is? Q3 minus Q1. You get the idea?
Wait, that symbol that you've drawn is the standard deviation, right?
Yeah. Which one?
That where it says 3/4 of IQR.
Okay, yeah. So first thing we did, what is mean? Mean is same as median, so that's not a problem at all. We know exactly it is 60. Now the question is,
Mm-hmm.
how do we find standard deviation? Correct? So
Yeah.
I'm saying to find standard deviation, you have to check the length of the whisker. Is it long? Is it short? Or you will say it is medium. Like, do you understand?
Normal. Yeah.
Accordingly, we'll have three conditions. One, a normal graph, one, which is more data right in the center, right? The one which is
Mm-hmm.
wider, where the data is spread more since the whiskers are long. Based on the type of box and whisker diagram, you can select what the standard deviation could be.
Mm-hmm.
If I'm
Right.
saying now, if the whiskers are long, which is case 3 for me, this one, long whiskers, correct? More spread
Yeah.
out. In that case, you use this value, 3/4 of interquartile range.
Oh, right. Is it always 3/4,
No,
or
I
is it
mean,
only when it's long?
yeah, it is almost this much, yes.
No, but is it always 3/4 of the
If it is
IQR? Like even if
longer,
it's
then yes.
oh,
Estimate.
so the shorter one will have a different thing.
If it is shorter, this is for longer, right? If it is
Yeah.
shorter, you can say this is 75%. What I'm trying to say here, 3/4 is 75%, right? This is 75% of
Mm-hmm.
interquartile range. But if it is shorter, we say this is 60%. We know in the case of normal, we can say this is 68%. You get the idea?
I'm a little bit. Wait, I'm a little bit lost. Why it's 68? I thought we were doing 50 plus 34.
Yeah. We'll work out that, like
Oh,
that also. We'll do like that calculation also. 50
all
plus
right.
34
Okay.
also we will do. 50 plus 34 also we will do. So we'll do both the calculations. Don't worry.
All right.
Let's look into interquartile range formula first. So interquartile range is Q3 minus Q1. In this case, 80 minus 40 is 40. And since I'm dealing this to be a normal graph, I'm saying 68% of interquartile range, which is 0.68 times 70, gives me a value, which is 27.2 in this particular case. So here
Mhm.
I get my standard deviation as 27.2.
All right. Okay.
So I'm just showing you one calculation. Is it okay?
Yeah. Yeah.
Right. Now, as you were saying correctly, we'll look into the rule. And this is, brings us to the second strategy. So for a normal graph, we understand that 68, 95, 99.7% rule is there for standard deviation. It really means what? 68% means that within one standard deviation, 68% of the data is there. Within two standard deviations, let us say two standard deviations, 95% of the data exists. And between three standard deviations, let me extend further, correct? Within three standard deviation, 99.7% data is there under the
How
belt.
did you calculate those values though, or
So
you just got to
these are
memorize them?
already calculated values, which you will learn soon.
Uh,
Which you will learn soon.
oh,
Next
right.
class.
Okay.
Next class. When you talk about the normal distribution, you will learn.
Mm-hmm.
But we are just
All
bringing
right.
that
Okay.
knowledge back here so that we can make a connection, because this particular question which you are working on is
Mm-hmm.
kind of in between. So, we don't have any explanation so far. So we are just pulling our knowledge, what you're going to learn soon.
Makes sense. Okay.
You get the idea, because we
Yeah.
don't have a base to answer this question at present. I will say that this particular question
Yeah.
is out of place for now. But since
Right.
you are asking me this question, I have no option. I have to
Right.
share with you something more, right?
Yeah. That's true. Yeah.
So this is a rule, right? 98, 68, 95, 99.7%. And therefore, I'm saying this is my normal graph. So I'm using 68% of interquartile range itself for easy calculations. You understand?
Yeah.
Trying to reconnect what you're going to learn, which can be used now in a very rough
Yeah.
approximate way
Right.
to estimate. Okay, now. So using this rule, and then what you were saying just now, 34% of the data is between mean and standard deviation, right? Of course, when we have 68 within, that means half of 68 is 34. 34 means 50 plus 34 is 84, is sum of standard deviation and mean, just
Yeah.
as we right. So we need to now find a point to find the standard deviation, which is 84 percentile, right? To get the standard deviation plus mean.
Yeah.
We know Q3 is 75 percentile, so we want 9 percentile extra. Assuming that the data is uniformly distributed, that is my assumption, now I can say that mean plus standard deviation is, in this particular case, 80 is my Q3. Do you see Q3 is 80?
Yeah.
Plus 9 out of 25, because this has 25% of the data. Q1, Q2, Q3, and Q4, you can see, are the maximum value. They divide into 4 equal intervals, so 25% data each. So that
Yeah.
25% data, we want only 9%, that fraction, 9 over 25. And the amount of data is, the maximum value is 100, and Q3 is 80. So 100 minus 80. So when you calculate this, you get 87.5 as the value of mean plus standard deviation. And therefore, standard deviation is take away mean, which is 60. So 87.5 minus 60 is 27.5.
Oh, right.
So we get another estimate, which is 27.5, which is close to 27.2, right? Do you see that? They're very close. So
Yeah.
say that in this particular case, your mean is 27.5 or 27.2, whatever you feel like, or given a multiple choice question, select the value which is within this.
All right.
If you
Okay.
have a multiple choice question, you could select the value which is within this.
Yeah. I'm just a little bit confused. Wait, so when we did 68% of the interquartile range,
Yeah.
and we got 27.2, but then why did we go through all of this process?
I showed you two different ways of calculating the standard deviation.
Right.
So we learned two strategies.
Yeah. Okay.
And from there, you
That
make
makes
a
sense.
selection. We have to be very
Yeah,
flexible when I'm trying to teach you, right? You may
Yeah.
have a question where some information may
You
not
can't
be
do that
available to
method
you.
probably.
Sometimes that
Right.
maximum value may not be available to you, right? They have only given you Q1, Q2, and Q3. How will you find standard deviation? Then you follow this method.
Yeah.
You get my idea. Then you follow this method.
So just one more question then.
Yes.
So that was when we did it for normal distribution. So let's say if we did it for one that was skewed.
We'll do it. We'll do it. Next
Right?
week. Yes.
Oh, okay, we're gonna do
We'll
it.
do
Okay, cool.
Have you understood
Yeah,
this
just
part? Let's
jumping
be very
ahead.
clear. Did you understand
Yeah,
this
yeah.
part?
So this is
Okay.
clear.
So
Yeah.
if it is a normal distribution, depending on your question, you're only given Q1, Q2, Q3, right? What will you do now? And then you have no option than to calculate Q3 minus Q1, which is interquartile range, and do an approximate calculation just as I have done, correct? And from
Yeah.
there, you will have to assume that this is kind of a normal distribution from the given data. You can calculate the value and your answer will be 27.2. And then from the multiple choice question, choose the right answer, which is closest. Easy calculation. Just do Q3 minus Q1, right? And then times 0.68
Yeah.
or
It's
0.7
clear. Yeah.
or 0.7. You may round it. If you want to be faster, 0.7, 70%. How does it matter? You are estimating.
Yeah.
Once
Right.
you do 70%, select the answer. I'm not saying 68%, 0.70%. Okay. You get the
Yeah.
idea? Correct. If you are
Because
given a
the
box,
multiple choice.
yeah, multiple choice approach.
Sorry, but if it was given, yeah, That's the better approach because it's quicker, you know. And even if they did give multiple choice like options, the values themselves won't be like to the
That
point
close.
decimal
No,
exactly.
no,
So
they
it's
won't
fine
be
if you
that
go
close.
to 70%.
No,
Yeah.
no.
So it's all right to do it like this.
Perfect.
Okay.
They'll give you like 28, right? 26, 27
Yeah,
point,
like that.
something, some values. So very easy to select from those, correct?
Yeah.
But if they give you complete box and whisker diagram with the whiskers and they are longer, right? If they are longer, correct? In that case, I'm
Yeah.
suggesting don't use 70%, use 75% because it is more spread
Oh,
out.
because it's more spread out. Yeah.
If it is
Okay.
shorter, use 60%. You
All
get the
right.
idea.
Yeah, yeah.
If it is shorter, then use 60%. It is more compressed, as I'm trying to show you right in the center. Does make
I
sense?
get it now. Yeah.
So,
Yeah.
because one question which you shared with me had 4 or 5 box and whisker diagrams. They had different lengths of the
Mhm.
whiskers. Some were longer, some were
Yeah.
shorter. Now, depending on which one to relate with which data, you could use this strategy,
Mhm.
right?
All right.
And
Okay.
use
Yeah.
60% to 75% to get your answer, depending on how wide the whiskers are. Correct?
Makes sense. Yeah. Hmm.
Correct. So this
Yeah.
part is absolutely clear. Now let's look into the right skewed information. So this is the data.
Oh, could I just,
Yeah, sure. We'll go back.
sorry, take a picture of the
Sure, sure,
last
sure.
slide?
Sure. A lot of information there.
Yeah. Okay, cool. Thanks. Got it.
Now, let's look into the right skewed diagram. So this picture shows you a box and whisker diagram where definitely we have much longer right whisker. That means the data here is distributed more towards the right? So it is kind of like this. Do you understand? So the normal graph which we were talking about will now be like this. There are a lot of values in this region, correct? That will result
Yeah.
in shifting the median to mean towards the right. So there we will see that the mean has been shifted. If this is median, then mean will be on the right. Since there is a lot of data, 25% of the data also has very high values. These high values,
Mhm.
for example, if I include the salaries of VIPs, I mean CEOs, CTOs, and managers, senior managers, for example, in a distribution of salary, right? So if there are a
Yeah.
lot of senior people included, then they will help you increase the mean, right?
Yeah.
So we
Because there's
expect the mean to
more
be higher.
values.
Yes. Now,
Yeah.
correlating to what you learn for a normal graph with this, we can say that when you have a data, which is in this case, I will say right skewed distribution, we have already understood that if we are given some value for median, mean is higher than Q2, right? Mean, because we have seen
Hi.
mean is higher than Q2. So you can say
Yeah.
from here, let's read the information which is given to us. We are given that the lowest value is 3 in this particular example. The lowest value is 3. Q1 is 5. Let me write down. So the value for L is 3. For Q1, it is 5. For Q2, which is the median, is 7. For Q3, it is 10. And the highest value we are looking at is 15. These are the values which are given to us.
Mhm.
Now, clearly, we can say when we talk about find the mean, so first thing we want to find is the mean. We have to estimate. We clearly know that mean is greater than median. That means mean has to be greater than 7.
Yeah.
So this is not the correct answer, definitely, because in this, we are given options here. Options are we are given different values of mean and standard deviations.
Hmm.
Let me
Yeah.
get back to the question here first, and then we'll describe. The question says, Amy, can you please read this question?
Refer to the box and whisker plot to estimate the value of the mean and standard deviation. Justify your answer.
Correct. And these are the choices given to you. These are the choices.
Hmm.
So you're given 4 choices. First choice is that mean could be 7 and standard deviation could be 3.75. Mean could be 7.45 and median could be 3.32. Mean of 8.25, median of 3.90, mean of 8.68, and standard deviation of 3.88. So we are given a combination of mean and standard deviation. We need to figure out which one is the correct answer. That is our multiple choice question. Is that clear?
Yeah.
Now, clearly, since we see that mean is greater than median, so this is a wrong option. We can cancel this out. Now, that value slightly greater than 7 could be the answer. All others are greater. They are possible combinations. Perfect. Now, we also learned that for a normal distribution, it was 84%, right? Which gives us the combination of
Mean
mean
plus
and the standard deviation should be greater than 84% in this case, since the data is skewed right.
So if it was skewed left, would you say less than 84%?
Yes.
Okay.
Since it is more than, so 84%, we know clearly this value here is 75% of data is up to Q3. So we are looking for a value in between here. If that is my combination of mean, which should be at least 10%. Do you see that? 9 will make it 84, correct?
So 10 would make 84.
85, correct? So we are assuming this to be approximately 85%.
Yeah.
Slightly more, right? So that is the calculation which I have done. Just to summarize our learning, mean is greater than the median. 84% of data is up to one standard deviation from mean. And this is for a normal distribution. This is for normal
Yeah.
distribution, right? 75% is up to Q3, you know that. That is standard for any box and whisker. Assuming linear distribution, instead of 84, we are going to 75 plus 10%, which is 85%. So we came to this number at 10% as 75 plus 10, which is 85%. Is it clear to you? Since it
Yeah.
is right skewed.
Yeah.
And we used our formula, which is Q3 plus 10 over 25 times 15 minus 10. This is 15, highest value, 10 Q3. And when you calculate, you get a value which is 12. So the sum of mean and standard deviation is 12. That is what we estimate. You get the idea.
Right. Yeah.
What you could do now is add mean and standard deviation
all of them.
and see
Then find which one's the closest to 12. Oh, right.
You get the idea.
That's so smart. Yeah.
12.
That's good. Yeah.
So just use a calculator. Tell me, what do you get for 7.45 and 3.32?
3.32.
Yeah.
10.77.
Which is much, much lower, right? Which is very, very close to Q3.
Yeah.
You can discard this value. Now, let's add the other two. 8.25 plus 3.90. What do you get?
12.15.
And if you do the next value addition, you get 12.56.
Oh.
So I will estimate this as my answer. It makes sense. In this case,
yeah,
it is higher than 7, correct? It satisfies my condition.
Because it's, yeah.
And the total is also very close to 12. My estimate of 85% was not bad, actually. You know, it is very practical.
Yeah.
It was on the lower side, and this is what I expected. I just
Yeah.
added 9-10%. That is how I'm going to answer my multiple choice question at this stage of learning. You get the idea?
Right. Yeah.
What I'm trying to, make you understand about this. It was very difficult to come up with this kind of logic, but however, I pulled everything, and then this is best I could explain you.
Yeah, this is really good. It's because I don't have, like you said, like a base for this topic, and most of the stuff for this is in next year, which they haven't taught us. Yeah. So yeah, this is really, really good. Yeah. So thank you, sir.
So now, can you summarize what we have learned today?
Yeah. So the main thing is, so with box and whisker diagrams, or like plots, the the things that I given are, it's like you can from the box and whisker diagram, you can figure out what the quartiles are and the highest and lowest value, but that's it. So, but that's what I thought was it. But so I was fine. One of the questions that
You get
that's the
5
reason I came
key
to.
points. This gives you 5 key points. Very simple, right? So the
Oh,
lowest
yeah.
value, Q1, Q2, Q3, and the highest value, highest data. This is what it gives you. Correct. Perfect.
Right. Yeah.
Yeah.
So I didn't think that you could find the mean and standard deviation from this, because yeah, I just didn't know how to. But then after this lesson, it's actually quite straightforward. Well, it's not that straightforward. I still need to get my head around it, but it is definitely easier than I thought, because I thought it was really complicated. So if we start, the main thing that I learned was the different kind of graphs that were shown. So first one is normal distribution. That's the usual one that we get in the exam. It's kind of straightforward, like it's given there. Yeah, bell-shaped. And then with then there's right skewed and then there's left skewed. So we did right skewed today, but the same principle applies for left skewed. So with the right skewed one, since we're saying it's right skewed, since it's drawn like this, you can see there are more values on the right hand side, and therefore the position of that graph would be as shown there. And so what we were saying, first we started off by just talking about the characteristics of normal distribution and how since the graph clearly shows if you have the median here, the mean would be the same as the median, which we say is at 50%. And then the value you need to just memorize is 34% of the data is in between the mean and standard deviation. So yeah, that's just a value that you've got to memorize. And that section there, which Sarah's just highlighted, is the mean plus the standard deviation. And with this method, when a table is given, let's say in a question like we've seen, how it says mean and standard deviation, and then it's given a few values, and you need to match those values with one of the box plots, you use this method by adding them and figuring that out. So yeah, but the main thing I learned was, like it's shown there, it says standard deviation can be estimated as 3/4 of the interquartile range. So I definitely didn't know that. So that's a good thing to keep in mind.
Depending on the type of distribution, right? It could be normal, it could be wider, it could be narrower. So we had two limits. One is 3/4 of interquartile range. The other one is 60% of interquartile
60%.
range. Right? So between that, 60 to 70%, you could say 60 to 70% to be, approximate. 60 to 70. Yeah.
But what's really clear about that is that it's not really like values to memorize and stuff, because it is kind of straightforward when you explained it. Because if you can see with the wider graph, obviously the percentage that you're going to use has to be a higher value than the other ones, since it's a wider spread of data, whereas the shorter ones you're going to have a smaller percentage. So like that, if you think of it logically, it will be right. But at the end of the day, it's only an estimate. So if you're 68%, 70%, we just need a quick round off so we can quickly pick out the values from the options given. So after we did that, we were talking about the whiskers and how the longer the whisker, we were saying, what was it? When it will be the wider one.
Maybe 70 to 75%.
It'll be higher values. Yeah. And then we kind of two methods were shown here. So again, I think here we were doing normal distribution. So we did 68% of the interquartile range. Finding the IQR is just doing Q3 minus Q1, and those you can just read off from the box plot and then get your value, which is quite simple. And then you just compare that value to the options given. But if you can't figure it out like that, which is very rarely because you're using a box plot, so you should be able to find the interquartile range. But if not, for some reason, you can use the other method shown below, which you again get a very close similar answer. So both work basically. And then we went on to right skewed distribution. And this was it's quite obvious, but it's good to still say it. So when you look at the median, you know that the mean has to be higher than the median, since there's more values on the right hand side, so all the data is skewed to the right. So that's why the mean is greater than the median in when it's right skewed. And then since that case, we talked about 84% for the normal distribution when you do the mean plus the standard
Correct.
deviation. But since it's right skewed, it has to be higher than that. So you're going to get like, let's say 85%, or it can be any value, but just needs to be higher. So it's easier if you just do it like this. Then you again use the same process, do 10 over 25, since we're dealing with a quarter of it, take your highest value minus your Q3, and then find your value, and yeah, you're done.
Yeah, you see that.
So it's
That was
straightforward.
it.
Yeah, it's a bit of a
So
lot, but like, yeah, it's
yeah, it
good.
took me time to come out with this reason, but I hope this really works. And I actually worked with many examples, and I found it really works with
It
all
works.
kinds of examples.
Oh, that's
So
good.
that's good. So I
Yeah.
actually took into consideration all the 4 or 5 graphs which you had sent. And if you try now this technique,
I
you'll
will. Yeah.
find mean and standard deviation for all your graphs without any problems, correct?
All right.
So just
Okay.
remember, if the
Yeah.
whiskers are small, in that case, standard deviation is very close to the mean. You can take a value which is around 60% of interquartile range. However, if the whiskers are long, then you could take around 70% of interquartile range. And within that, you will get your estimate, which will be close enough to answer any multiple choice question on this topic. Okay.
All right. Wow. Okay. Cool. Well, that's yeah, that was everything was literally brand new for me. I didn't learn it at all before. So thank you so much, sir, for like introducing me to that at this early stage. So
Yeah.
yeah.
Thanks. My pleasure. So we'll continue with
Cool.
this, and let me share with me any other questions. We'll discuss them later. Okay.
Yes. All
Great.
right. Thank you, sir.
Great.
Bye. You too.